Okay, hello everyone. It is 10:30, so I think we should get started because we have a lot of really great content today. My name is Jessie Pinchoff. I co-lead the Population Council's Population, Environmental Risks, and the Climate Crisis, or PERCC initiative, together with my colleague Vidhu Mahapatra, who's based in New Delhi. The PERCC initiative was launched in 2018 to investigate the complex interactions and dynamics between people and their environment. The initiative helps to ensure that climate programs and policies are progressive, inclusive, and rooted in the principles of equity. And PERCC has three primary focus research areas: gender equality and adolescent health and well-being, sustainable livelihoods for economic empowerment, and harmonized demographic and climate modeling, which we'll be talking more about today. So as part of that area of work and the Council's commitment to open data, we are excited to welcome colleagues from across the globe as we launch a new interactive data visualization website for the Community Demographic Model, or CDM. So I will hand it over now to my colleagues, Lewin Jiang and Hamid Zaraigan, to share more about the CDM itself, to introduce the website, and to introduce our panelists for today. So thank you.
Thank you for the great opportunity for introducing the community demographic model. I will use about 10 minutes to briefly talk about why demographic modeling is important and why and how we develop the CDM model and how we apply CDM model for research. Population dynamics is always considered as a key component for socioeconomic and environmental assessments at a global, national, and subnational levels. Examples include the UN Global Environmental Outlook, Millennium Ecosystem Assessment, the IPCC Climate Change Assessment reports. This is because human population and their activities induce the man-made environment and climate change. In the meantime, human society bear the consequences of climate change. UN Population Division has identified 4 demographic megatrends that have profound implications for our future. They are population growth and regional variations, urbanization, aging, and migration. In addition, we argue that there are other 2 major megatrends, namely increasing education attainment and shrinking household size. These demographic megatrends, combined with the changes in consumption and production behavior, could generate important implications for climate change, which have already attracted increasing attentions from climate change research communities. To develop the new IPCC socioeconomic scenarios, experts on the environmental and climate change are interviewed and requested to tell what the most important factors in meeting climate change challenges are. Here are the lists for meeting the mitigation and adaptation challenges: population, urbanization, and population in coastal areas, and education are considered the most important factors. According to the IPCC 5th Assessment Report, climate risk is a product of climate hazards, exposure, and vulnerability. The latter 2 are largely driven by population dynamics. Humanity is facing inevitable climate change, and the human population, its sizes, characteristics, spatial distribution are also changing, and so do their vulnerability and adaptive capacity. To build a sustainable future, livable environment, and just societies, we need to understand how many people will be affected. Will the people be under attack directly, and who are those people? In the IPCC new socioeconomic scenario, the Shared Socioeconomic Pathway, or SSPs, for the first time includes demographic projections as its core elements. The quantitative projections are made for each of the 207 countries. This chart displays the aggregate global results under each scenarios relative to the levels of 1950. Changes in population is in red, changes in urbanization in purple, education in green, and GDP in blue. The SSP scenarios and its quantitative projected results are widely used among the climate change and environmental research communities. The Integrated Assessment Modeling Group at the National Center for Atmospheric Research, NCAR, where we worked before joining the Population Council, used demographic projection combined with detailed information on household income and consumption behavior as input for projecting changes in economic growth and emission using a computational general equilibrium model, PET model. The results are in turn as inputs of the Earth system model for modeling the climate changes in climate system. The projected changes in climate, population, GDP, and the emissions are downscaled to grid cells to determine climate risks in different parts of the world. The past decade could be considered as the golden period for demographers to contribute to environmental and climate change research. However, there are still some limitations and barriers to overcome. The climate change and other global assessment scenarios usually pick up demographic projections from some existing projected results from the UN, YASA, or other institutions. Once the projections are chosen, it would be used for at least 10 years and hard to change. Those projections are usually for global scenarios and do not consider local settings. They use conventional methods and only produce results for population size as a scalar, leaving alone other important demographic factors. The whole process usually involves very few producers and do not engage the large communities of academic research and policy analysis. CDM model was developed to meet the challenges and overcome the barriers. It provides the models and tools that are available for timely users. It allows developing consistent scenarios according to the social, economic, and environmental contexts at a global, national, subnational, and spatial levels. It adopts the advanced methods and models to robustly project the changes in population size, composition, and distribution, reflecting the demographic megatrends. It provides open sources for community use, contribution, and collaboration. The CDM model has 4 components. The urbanization projection model is an extended and improved UN model. It is based on historic data and machine learning methods to project changes in the share of population living in the urban area. The population projection model is based on multi-state demography, accounting for the bilateral flows of internal and international migration for the whole region and its subregions. It projects the changes in population by age, sex, urban-rural residents, as well as other characteristics such as education, race, ethnicity. The household projection model converts population projection into household projections. It is based on the extended headship rate model to project the changes of population living in households by age, sex, urban-rural residents, and education. The population and the household projection results are downscaled to grid cells at a 10 or 1 kilometer resolution using a high-resolution gravity-based population downscaling model. The demographic projection results are used to carry out mitigation and adaptation analysis. The research of climate change in turn help to inform the changes in demographic projections. CDM model has been applied in developing scenarios, research, and policy analysis. For instance, the urbanization model was used to generate urbanization projections for the SSPs. The results are published at the SSP spatial issue in Global Environment Change. The CDM population household urbanization model have been used for projecting energy consumption and carbon emissions. The results are published at PNAS, Energy Economics, and Natural Sustainability. The CDM urbanization and spatial downscaling model are used for projecting wildfire risks, air pollution, hazards, and mortality. The results are published at the Nature Climate Change, Lancet, PLOS Medicine. We hope and believe that CDM could make good use by the research communities. Next, Hamid will walk you through the main features of the model and tell you how to use the website for your own purpose. Thank you.
Hi, everyone. Welcome to this webinar, and thanks very much for attending the webinar. In this part, I'm going to demonstrate the CDM website and some of its capabilities. In the main page of the CDM website, in the Scenarios tab, we describe the current socioeconomic scenarios that we use for our projections. These scenarios are called the Shared Socioeconomic Pathways, SSPs, and are endorsed by the Intergovernmental Panel on Climate Change, IPCC, and can be linked with climate scenarios for human-environment dynamics. These scenarios influenced by policies, technology advancements, and cultural shifts have implications for alternative future trends in population size, age structure, migration patterns, urbanization level, household composition, and the spatial distribution of population. The Models tab contains links to all of our current 4 models of the CDM. I am not going to show all features of the models and refer you to each model's tutorial video for a more comprehensive demo. Nonetheless, I'd like to draw your attention to some interesting capabilities. The household projection model projects household compositions consistent with our current scenarios. It shows a number of households with several sizes based on different characteristics of the household head for several world regions and individual countries. For example, the current visualization shows the number of households with different sizes and according to the age group of the household head and their education level in 2050 for India. The first scenario, namely SSP1, is sustainability oriented and calls for investing in human capitals such as education. We can see many households falling into the highest education category. On the other hand, SSP3 is a scenario with the least emphasis on increasing human capitals. And we see much lower highly educated population according to these scenarios. Households represent the consumption unit of energy, and having their projections benefits mitigation plans. Moreover, the model contributes to vulnerability analysis and policies that build resilience. For example, what is the projected number of elderly one or two member households that have the least adaptation capacity and education level, and are therefore the most vulnerable to climate change effects. Household projection models this type of multifaceted questions. The urbanization projection model projects the urbanization level, which we describe as a percentage of population that is urban, for all countries and subnational territories of the US, China, and India. Urbanization level of a region has direct consequences on its adaptation and mitigation capacities in relation to climate change. The model's outcomes for all countries have already contributed to the IPCC reports. We also extended the methodology to the subnational territories of the US, China, and India to better account for spatial heterogeneity in urbanization levels within these countries. For example, the current line plot shows urbanization trajectories for North Carolina. To address multiple outcomes, to address multiple potential outcomes and provide a range of projections over the century, our model produces 9 alternative trajectories. We plan to extend our subnational urbanization projections and have already produced them for Mexico and Pakistan as well. These trajectories can be mapped to different scenarios to account for different differentiations in scenario and their consequences in urbanization projections. Both the urbanization and household projection models can receive inputs from the user to produce projections accordingly for their region of interest, if their input files follows specifications outlined in the help messages. The population projection model unveils projections of multiple demographic characteristics at the subnational level consistent with several scenarios. The current results pertain to the US states, with current plans to extend the analysis to Mexico, Pakistan, and other countries. The model is composed of several components, and I'm going to give you a quick tour of each one. The migration flows shows maps of in, out, and net internal migration flows for each US state. For example, the current map shows the number of migrants according to SSP2 in 2050, which represents the highest similarity to historical trends in terms of various socioeconomic factors. So SSP2 basically serves as a business as usual scenario. The age structure tab shows changes in age structure over the century for each US state. The current plots, for example, clearly show the aging of population according to SSP2 scenario. The demographic trends tab has several visualization types. For example, the current demographic contributors line plot visualizes how much of population change in Colorado can be explained by natural growth, internal migration, and international migration. It shows the decreasing effect of natural growth and internal migration, and the increasing effect of international migration, in a way that after the 10 years or so, the international migration will be the #1 factor of population growth for Colorado. The internal migration line plot provides a closer look at the relationship between the in-migrants and out-migrants for each state. For example, the current line plot shows that each year, Colorado will receive internal migrants more than sending them out until the later decades of the century, when the in-migration and out-migration will balance each other. The final tab is the population change maps that visualizes percentage population change compared to 2010 for the US states, consistent with the selected scenario. Finally, the spatial population downscaling model visualizes spatially explicit representations of population for each subnational territory. The current results are available for each US state and show the total urban and rural population for each 1 kilometer by 1 kilometer pixel within its boundary. The current visualization shows the spatial distribution of total population for Georgia in 2050, consistent with the SSP2. Different socioeconomic scenarios lead to different population distribution outcomes. For example, the SSP3 is the scenario with low urbanization and population growth. Conversely, SSP5 is a scenario with high urbanization and rapid population growth. And SSP2 is a middle ground scenario with the highest similarity to historical trends. The current visualizations show different outcomes of rural population distribution for Georgia according to these scenarios. We can see dramatic differences in rural population distribution across the scenarios. These outcomes, combined with climate projections, lead to distinct realizations of the rural population exposure, in this example, to climate hazards, and therefore different policy implications and resilience building programs. Thanks very much for your attention to these models. And I hope you will learn more about all these demographic outcomes by interacting with the website. If you have any questions about the models, please reach out to us through the contact page of the CDM website.
Please go ahead and start the panel discussion.
Okay.
Please introduce the panelists.
I would like to, at this point of the webinar, I would like to invite my colleagues, Deborah Balk, Jose Miguel Guzman, and Brian O'Neill for our panel discussion. All our panelists are experts on scenario-based demographic modeling for human environment dynamics, for which CDM can serve as an important technical set of tools. Deborah is a director of the City University of New York's Institute for Demographic Research. She is also the co-chair on the fourth assessment of the New York City Panel on Climate Change. She is an expert on the interactions between Earth and social science data to address interdisciplinary policy questions. Jose Miguel is the president and founder of No Brainer Data, with notable contributions to the United Nations Population Fund, UN Regional Commission for Latin America and the Caribbean, and the Demographic and Health Survey Program. He's a thought leader in demographic dynamics, international development, and climate change adaptation. Brian O'Neill is the director of the Joint Global Change Research Institute and an Earth system scientist who studies the relationship between future societal development, emissions, and climate change impacts. He had significant role in the creation and development of the CDM as the group leader of integrated assessment modeling in the National Center for Atmospheric Research. Thanks very much, Deborah, Jose, and Brian, for accepting our invitation. Before starting the panel discussion, you can type in the questions at any time in the Q&A option. Please specify who is the recipient of your question. We collect your questions and ask them during the Q&A session at the end of the webinar after the presentation of our colleague, Ricardo Regulus. So, Deborah, I have collected some questions for this panel discussion, and I'm gonna start the conversation with you as the co-chair on the first assessment of the New York City Panel on Climate Change. So my first question is, how do you think about the importance of scenario-based demographic projections for climate change impacts and human environment dynamics in more localized scales, where this adaptation policies matter the most. And Jose Miguel and Brian, please chime in at any time you see fit to just continue the conversation. So Deborah, please go ahead.
Thanks, Lewin and Hamid for having me. And I'll start with this is a challenging question to answer first. So I think that the website that you've put together and making available these data and visualizations is a really critical part for anybody working at like a global, national, or regional scale. But the short answer to the question you posed to me is I think our work is cut out to put in place these very tools at a more local scale or at a city regional scale. And that doesn't mean it's not desirable. I just think it requires a shift in the way we think about it. There is great interest in doing that, but we're not quite there yet. For example, when one works at the scale, let me say I came to this meeting from a meeting of the NPCC co-chairs for the fourth assessment. And, we definitely front and center in that assessment is thinking about racial equity as part of the future of New York City as its interfaces with climate change. And this is an issue that is a little harder to envision in the global and regional downscale models at the present time. So I would see that but every city in the United States and probably globally has similar concerns, and particularly when we think about climate adaptation or we think about solutions for mitigation. This is areas where we want an equity lens front and center. And so I would say these tools, it's a really good time for us to think about how to continue to evolve these tools with those kinds of objectives in mind. I do think it challenges the way these tools are very helpful going out into the future. They talk about uncertainty a lot, and those tools, that's really, really valuable for anybody working at a regional or local scale to visualize that uncertainty. So that's another area where I think demonstrating the kinds of uncertainty and what that uncertainty might mean in a specific place is really relevant. So it does push the limits of how precise we can be in any local and for any locality. So I see that as a welcome challenge for us as a community of people working, of both scholars and practitioners, but it's not where we're at yet. But doing exactly what you've done to make these data available to set the stage for that work is also like a first step in a conversation that's very productive. And so I guess that is my that's the lens with which, that's the baton I can pass it on to Jose Miguel or Brian if they care to speak to that point in particular, because that stage setting is a really, really critical part. The SSPs live in or come to us from a global context, and we do live within that global context, as the last 2 years have currently made clear, if nothing else.
Well, I think this, thank you, Deborah. I think I agree fully with what Deborah said. One of the issues that I think is more relevant for this scenario building, these models, is that it brings together what is more the demographic oriented projection to the climate projection. And I think this is something that is extremely relevant, because you can make projection and that you can use for climate change, but I think if we do that independently of what have been the different scenarios built in the IPCC, we are missing an opportunity to really connect both worlds. And we know that one of the ambition is how we can connect the work that we do in the demographic area to the work that is being doing in terms of both mitigation and adaptation to climate change. And bringing together these two worlds is not just academic issue, is an issue that has repercussion in terms of the work that is done in the country and at the local levels. I agree with Deborah in terms of the local, how we can move as fast as possible to go to the local levels. And we know that at the local level, the scenarios are like has been built basically at the global level. And climate information, climate change information is more at the global level. We need to go also with that information at the local level, because at the level of community, the people cannot access that information that could be too sophisticated for them. And if they try to get in the market, maybe too expensive. So how we can go through the local level with more information, more detail based on those models. And I think this is a relevant point. And together with that, I think that as we know, we are moving at an open data society. More and more information is collected from the bottom. And then for me, one of the challenge for the future, but we are just starting the discussion. I'm talking already about the challenge. But anyway, I think that one of the challenges is how we can move later in the process to incorporate more and more the information from the local level. And I think it's good that you add in the modeling that you input your own data. I think this, the possibilities that are open with this model are really fascinating.
I'll just add a couple words, maybe from the big picture scale, the larger scale perspective. But first I wanted to just thank both Leywin and Hamid, and also the Population Council for making this all happen. Lots of people over many years have contributed to the development of this CDM model. Lots of institutions have, but really Leywin has been the driving force all along since the very beginning. And Hamid most recently has really made everything happen that you're seeing on your screen. Otherwise this would be, a pile of code on someone's hard drive somewhere. So really many thanks to them. And I, just as a reminder, I think as something that Leywin was trying to expand on before he had technical difficulties, is that how important population is as an input to global, regional, and local scale analysis of environmental issues. It is a necessary component to any integrated environmental analysis, both because population is a driver of the environmental issues we're dealing with, whether it's emissions or land use driving climate change or for some other issue, but also because it is people who are going to be affected in the end. So it's an important determinant of vulnerability, who might be affected more so than others, and where. I do want to point out that doesn't mean that population policy is always the most important response to an environmental issue, but it is one of those considerations on the table, along with lots of other approaches, and that the kinds of projections that are being produced now that Hamid showed you, you can see we've gone well beyond just projections of population size. So when we're thinking about what drives environmental issues, what determines vulnerability, and what kind of policy options are there, we, 20 years ago, maybe we just would have been focusing on population size. But now we're thinking about how does migration policy have to be designed to account for the potential for climate migrants to be a growing part of the migration picture? How do our urbanization policies and development policies need to change given the outlook for future urbanization in different parts of the world? Coastal development, right? Deborah does lots of work on this. And how do we need to think about coastal development policy? This is all demographic policy questions that need to be informed by the kind of projections we're seeing here. If we were having this session 15 years ago, we would not be looking at a screen full of the kinds of projections that Hamid just showed. We'd be showing what will the population size of Mexico or the US or Nigeria or something look like 50 years from now. Now the demographic field looks at urbanization, gridded projections of exactly where people might be living, household arrangements, and if we're pushing, as Deborah mentioned, into other characteristics like race and ethnicity, I would add income distribution to that as additional characteristics of people and population that are important to determining vulnerability.
Can I just add to what Brian said, which is, I would say, Brian mentions policy, and I would say that that's policy with a small p, because we care as much about the trends of populations, whether they're it's migration or urbanization, for example, or even household living arrangements and household size that may occur outside the policy domain. They may interface very actively with the policy domain, but many of those processes occur in spite of policy. So, and it may be a policy not in that domain that influences those broad scale trends that we care about. So I just wanted to, I'm not trying to clarify what Brian said, but my perspective on policy is it's a small p, not a formal policy necessarily, that we could be both.
Yeah, thanks very much to all of you. This is great, and I'm really enjoying this conversation. And many of the points that you mentioned and alluded to in your responses basically are reflected in my following questions that I hope we can expand even more when we get to them. So for this modeling, as all of you mentioned, this is just a starting point, and we hope to gain more and more insights and feedback to build our projections, to extend our scenarios to more localized levels, to just better respond to specific needs in different parts of the world, and also produce projections, as Brian mentioned, not only just for population but for other demographic variables. There are always challenges, as Jose Miguel also mentioned, because you need to collect a lot of data and just standardize them and make sure that they can be put together in a way that are meaningful and everybody can understand them. But we are very excited to be on that path. I have been working on this field for some years, and I'm always thinking about how can we support compelling and compatible ways to combine demographic projections with climate projections to bridge the gap between demography and climate research communities. So, we have these population scenarios that are based on this SSP scenarios that, they are not climate scenarios. They are based on people's adaptation and mitigation capacities and many other socioeconomic aspects. But for me as a researcher, at the end, the most valuable output would be to combine this with climate outcomes in a meaningful way, so that we can answer some interdisciplinary questions, like what is for example, in this specific city, let's say, for example, Phoenix, what is the exposure and vulnerability of population to extreme heat events in the next 50 years? So I'm going to start this question with Brian, and we'll get to Jose Miguel and Deborah to move the conversation forward. But Brian, as a person that you are a world-class scientist in this field. So what do you think we can do to better bridge the gap between climate scenarios and population scenarios and be meaningful to both communities?
Well, there are a number of technical things that can be done, and you can imagine taking your CDM website and expanding it in the future in lots of different ways, but including with incorporating current environmental data and also projected outcomes, for example, for climate hazards, heat wave frequency and intensity for the future, for Phoenix, for example, drought conditions, and overlaying this with anticipated population trends and trying to anticipate where might we have some hotspots of problems, you know, vulnerable people with increasing hazards for the future. And that, you know, some of that's been done. You've done some of it. Hamid Lewin has worked on it. And I think there's lots more interesting work that can be done on that. But really the thing I want to emphasize is that for making this connection between demography and climate science, a critical thing that's only started to happen recently is that demographers are really participating in that work in person. And so the projection field, the demographers producing projections in the old days used to produce their projections, kind of post them somewhere, throw them over the wall, and then the environmental field users were just left to like, well, you can take the high, medium, or low, and that's it. That's what you've got. You got a list of numbers, 3 columns. In order to connect those to integrated scenarios for the future, what you really need is the demographic expertise for what do demographers think would be going on in the world that would actually produce a low population outcome or a high one, or a rapidly urbanizing one, or one with a lot of sprawl or not. What are those other socioeconomic conditions? You know, income, regional differences in economic growth and wages and opportunities. It may be policy conditions, inequality, things like that, that would actually produce those. Because in order to integrate the demographic scenario into the environmental analysis, that's the connection. It's what's going on in the rest of the world, because those other things are also going to be determining the environmental conditions. So when you want to put together environmental conditions and population conditions that make sense together, they are connected by the underlying socioeconomic trends that are going on in the world and determining both of them. And so over the past 5 or 10 years, demographers have increasingly participated in this interaction. There's a long way to go there. And so that's what I find attractive about the PERCC program, is that yes, you've got a website with technical outcomes, but you also have demographic expertise and people dedicated to working with other communities to integrate them, not just throwing them over the wall and saying, you know, do what you want with these things.
If I may, you know, say something about that, I think when Lewin was saying, when Brian was saying about what we were doing 15 years ago, I remind me what we were doing when I was a UNFPA, and we were meeting with some of you guys and discussing this issue. And clearly we were like, not at the point we are now. I think the progress has been made in terms of improving the participation of demographers. And I think Brian is one of our, you know, best example of this participation. But you mentioned the city of Phoenix and, you know, and the heat waves and droughts, and that make me, you know, like to add that when we make this projection, when we link population change to climate change issues, it's very relevant that we are hazard specific, meaning it's very different, the kind of impact and in terms of household, in terms of income, in terms of age that you can have if it's about a hurricane or it's about a heat wave. And it's about the, you know, the time of the impact, the duration of the impact, the prediction of the impact. There are so many things that are different depending on the type of hazards. And I think this is very important that we incorporate that dimension in terms of the data. The other thing that I wanted to say is about when we do that, let's say at the country level, or in the case of the United States, at the state levels, we need to consider those issues of hazard specific, but also the areas in which the effect will be bigger. Obviously, if we are talking about heat waves, the area with elevation is higher, you know, it's altitude obviously will be a protection in many cases against heat wave. So it depends, you know, what is the situation or the geographic particularity of the country. But it doesn't matter what we are trying to measure. We need data, and we need data at disaggregated level. And I wanted to bring this other issue because, you know, in order to really make good planning and good projection at the local, at the country level, at the local level, we need data that are really disaggregated with a level of granularity that can, you know, can be compared with other kind of data from the kind, let's say, climate change data. We have difficulties in getting those data. Now with COVID, many censuses have been postponed, for example. So the information that we are getting is limited now. We have to wait for many countries. Also, many countries are reluctant to provide this kind of data at that level. I think that Deborah knows very well that because she has been working and suffering and enjoying both at the same time. How can we use those data?
So I'll take that baton from Jose Miguel. And yeah, I and also comment both on some of the themes you just raised as well as Brian's, which is, you know, I know we have a lot of demographers and population scientists and demographically inclined allied scientists in the attending this, and maybe I'm preaching to the choir here, but as a community of scholars, I think we've lost our, you know, it's time for us to reflect a little bit on what we can do to put ourselves in the context of understanding climate change, not just the impacts, but preparing for climate change. So I think that over the last 50 years, demographers have really moved away from mostly, you know, a science that's been oriented toward understanding population futures and tools for projections, even though those have radically advanced, but especially at the local scale, we still use like a cohort component of, we can't, you know, we use a cohort component approach with like a local land use model on top of it. And those models are like increasingly perhaps poorly fit for some of the spatial distributions that I hear Jose Miguel pointing out. And so we, as a need, the need for planning, we're not tooled that way to do it. So we need to, and so while there has been in the last, you know, couple decades in particular, a movement away toward more probabilistic approaches and expert infused approaches in the projection community of demographers who do projections, at the local scale, we haven't had those same advances. So we have to go back and think about that. And I'm going to double back to data in a minute, but I also want to point out that the demographers have been, I think, increasingly inclined on understanding the impacts of climate change on population rather than understanding the contribution of population and population composition and characteristics to climate change. And so, again, that's I mean, I heard what Brian said is like bring demographers to the table who want to think about that part of the problem too. And there have been a few, but that's a smaller community. And I think that especially the more we begin to think about ways of, you know, there might be feedbacks in the systems, those communities have to come full circle. So I just want to also point out that as we move toward a community, a global community where we have lower fertility, hopefully lower mortality, the demographic process that we're going to care most about is probably migration, and perhaps related to it, of course, urbanization, right? And urbanization has been the weakest link. It's not so much a characteristic thought of in the demographic community the same way fertility, mortality, and migration are. They don't go into that balancing equation. And therefore, but yet it's a property of place, and it really begs some of the spatial questions. So we as a community need to embrace spatial methods and make them our own, and we are not there yet. So, and associated with that, we need to push the data infrastructures in which we operate to do a better job. We do not collect migration data the way we collect fertility and mortality data, period. If we want to do, so I don't think we do know certain things about migration that are really relevant. We know that there's a very clear age pattern to migration. Whether that same age pattern will hold in the future in the context of more climate-induced migration is an open question. But we do know the same kind of things that we've relied on historically to understand population change about migrants, not so much the migration flow. We do a better job at understanding international migration because we know when people move across borders. But to the extent that much of the change we're going to see is going to happen within internal, within national borders, and maybe that itself will also be a precursor to things that happen between countries, we need to do a much better job of participating in making sure that better and new data can be used to understand that particular process and connect it with the other data that we have. I mean, both in the demographic domain as well as in the climate science domain.
Yeah, thanks very much to all of you. I think these are very important points, and I'm just going to start with your points, Deborah. That we need to collect more and more data, and especially migration, because migration is one of the most important factors. That it's one of the adaptive measures that people use for climate change, and when you work on these models, always migration is the most challenging demographic variable to collect. Even for very data-rich countries, we always have these issues. And if you go to some other countries, then this challenge is aggravated. But I hear you, and I think we should be very diligent on collecting this data and make sure that we take into account all of this. And in terms of probabilistic methods, I think this is a very important point. And these challenges in collecting data and putting them together using traditional methods make me always wonder that we need to move more toward this data-driven and machine learning approaches that could use patterns in the data to produce projections and also produce uncertainty measures. But at the end of the day, we should also pay attention to the balance that we should provide these projections in a meaningful way that are also interpretable. But I think we need to be more active both in terms of data collection and also novel method that could be applied to different parts of the world and also take into account all these different factors. And the other thing that I just think is important to mention is this type of the event type of the climate hazard that we are going to consider, as Jose Miguel also mentioned, because I was looking at the other day. I was looking at a map of precipitation changes at the municipality level for Mexico in the future, and I could see some patterns in decreasing precipitation and increasing precipitation. And I thought it would be very cool to have projections, for example, of people's participation in the agricultural sector and see how they can be affected by this changes in climate variables, and just add some other dimensions to this vulnerability of population to climate change. And as also Brian mentioned, we need to make sure that we have more conversations between these different groups. And I remember that when I started this, and this could sound like a confession, but the climate projections would kind of look very esoteric to me. But I think, fortunately, I'm not there anymore, but I think this kind of conversations that Brian mentioned always help to make sure that we are on the same table and talking about the same thing and serving the same purpose. So my other question is about this equity that you all mentioned in your previous responses. One of the central themes of PERCC is also maintaining is about equity and climate justice. And this is a very hot topic, and it's very important because people are affected by climate change differently. And people that have less resources most of the time happen to be more affected by climate change as well. So this brings me to this question, and I'm going to start this with you, Jose Miguel. How can these projections support policies that build resilience and adaptive capacities to enhance equity and well-being? I know you've always, you all mentioned this in your responses, but if we can focus more on this equity and climate justice piece at this time, I think that would be very helpful to me and hopefully the attendees.
I think equity must be in the equation of climate change, because we know that already that with, let's say, take the case of hurricanes, they are the poor, more disadvantaged people that suffer the most. And I think if we, I think it could be interesting to look at what could happen on climate change under the light of what's happened with COVID-19. What we have seen is that all indicators that we have calculated until now in terms of lethality, in terms of mortality, in terms of life of expectancy that is lost because of COVID, clearly affect more some people than others. So we know now, I think COVID has given us the, sad, if you want, opportunity to understand the kind of thing that could happen with climate change in a bigger, even bigger scale, with more impact and more sustained, because we hope that COVID will be eliminated soon, or at least not eliminated, but at least mitigated. How soon, we don't know. But I think this is clear for me. Let's use this experience to show again that, we have not been able to practice, justice with COVID. Let's see if we can do that with climate change. And I think that goes for both sides, for both mitigation and adaptation. Adaptation because we know that the vulnerability are bigger, but also we know that the lack of capacity for people to deal with those vulnerability. We know already that people that can migrate in these circumstances are those that have some resources at least. Maybe they are not rich, but they are, maybe they are poor, but they are not the poorest. The poorest, they cannot move. The migration is not part of their adaptation options for them. So we need to consider that part. And the second part is in terms of mitigation, is that we already know where emission has been mainly produced. And so if we, I have been thinking what happens if we calculate we weight the number of people by their capacity to produce emissions, so like consumers. So that means maybe the population of some area, some region is not so big as we think now. Because if we have to compare in terms of emission, we should compare things that are comparable. And we can calculate some kind of population weight by consumption. And that may be the impact. And then we will see that again, that the poorest and more vulnerable people, they are not the ones that are really producing emissions. So working in that equation help us to create, to build stronger arguments for climate justice.
I can jump in to say, and maybe give an example or two, that I think that the fundamental role that projections like the ones that CDM produces play in analysis that includes aspects of equity is just providing, right? So equity means some people will be affected more than others. And so to address questions like that, we need to know, well, what kind of people, what types of groups are we talking about? How many of them might there be in the future, and where? And that's a starting point for any analysis to then see, well, will one group of people be more affected than others? So those groups may be race or ethnicity, they might be income, they might be geographic, rural versus urban, or different age groups. But in order to do any analysis, to look at what the equity implications of environmental impacts might be and what we might do about them, we have to start with this basic information of, okay, what are we talking about? What's the landscape of what the differentiated groups of people, not treating them all the same, might look like? And that's where the CDM can come in. I also want to just use as an example, one new area of concern is, right, traditionally we kind of think of demography and equity issues both that are a determinant of environmental impacts, and as that environmental change may impact people. Another thing that may impact people is doing something about climate change. So either adaptation that goes wrong or mitigation that has, emissions reduction that has unintended consequences is a very important topic that's being looked into right now. And so, for example, the projections of the US that Lewen and Hamid have produced, and that Hamid showed a little bit about, have already started to be used in some work funded by the Department of Energy that's going on partly at the Joint Institute where I am. On looking at those questions. So some work has already been done on using those spatial projections to help think about where might future power plants need to be sited to supply new demand in the future. A project that's just getting underway is looking explicitly about what about some of those unintended consequences. If we're looking at massive decarbonization, really rapid, complete transformations of the energy system to reach our climate goals, that's likely to have some unintended consequences. How will prices change? They may be higher for some groups than for others. The issues with the potential unreliability of renewably based electricity grids before we have batteries that can take up the slack when the sun's not shining or the wind's not blowing. Who's going to suffer from that unreliability? And in order to investigate those kinds of questions, you need to start this, well, where will demand be? Where might lower income people be primarily settled or disproportionately settled, or certain race or ethnicities? And in order to look at that question of what we might do about it. So it's a really important piece to that kind of work.
So can I jump in just on this point? So like one question is, who's energy insecure in the present period, right? So if we know who's energy insecure now, we can think about at local planners, national planners, global planners can think about ways to make them energy insecure in the future with clean energy solutions. But we need to know where the energy insecurity is now. And that is, to start, I think, we shouldn't expect people who are already energy insecure to become less energy insecure unless we are very targeted in trying to reduce that inequality. And some of but to this point, some of that will have to be done spatially, but some of that doesn't have to be. And some of that can be done in the bigger containers in which we already have pretty good data. So one really nice thing about the CDM model and this website is that it makes available visuals and for people to look at. I would encourage us as a community to think about how to express uncertainty associated with these things. Some of what we see is like, there is some certainty that's being presented here because we have bands that we expect these things to happen within the various highs and lows that are presented. And I think that the more we, so at some scale, we can be pretty certain. And then as we, just like any weather forecast, right? Like we know we're gonna get a really strong storm somewhere on the East Coast of the United States. We don't know if it's gonna be a direct hit for New York City or for, the Long Island or for, Connecticut. And so, and we have to live with that uncertainty. But I think in our own, in our scientific endeavor, even though we have paid attention to uncertainty, this suite of activities require that we double down on that and do and be a lot more transparent, be really clear where we know things or probably know things. As we know, it's going to be, the future will be warmer, the future will be stormier, we know that. But like where we don't know it, we should also be clear. We shouldn't like mask over that, because we have more work to do. And if we mask over it, it seems like we already have answers to these questions. We don't know which cities are going to grow. We don't, I mean, we're working on that, right? That's a question, but we don't have really good data that inform that question at the present time. We don't know where these energy insecure individuals are going to be in the future. We haven't, but we might know something about where they are now. And that will be a basis for thinking about where we can find them in the future. But we should be clear when we don't know something just as much as we should be clear when we do know things.
Yeah, that's a great point. And I think we should always focus on uncertainty as well, and that's one of the directions we're going to take. I have a few more questions, but I think now it's the time to go to the other presentation, and I hope that we can continue picking up on some of this very interesting and important points in the Q&A session. But I'm really thankful to all of you for sharing their insights with us. And you've already, even for those questions that I didn't have the time to ask, your answers overlapped with some of those points that I was hoping to get when posing those questions. But now it's the time, and I hope we can enrich this conversation during the Q&A session. But now it's my pleasure to introduce Ricardo Regules, our colleague at the Population Council's Mexico office, to present about some applications of the CDM in Mexico, as well as its potential and future directions and policy implications. Thanks again, our panelists, and Ricardo, the stage is yours.
Thanks, Hamid. Hi, everyone. Thanks for the presentation, and good morning, good afternoon, and good evening, everyone. Before I start with the presentation, I'd like to thank Lewin and Hamid for asking me to be part of this event and inviting me to present the CDM related work that we are conducting in Mexico, and to showcase its potential for future research on the intersection of climate change and population dynamics. Thank you again, Hamid and Lewin. And next slide, Corinne. Okay. All right. As some of you may know, Mexico is one of the most urbanized countries in the developing world. Nearly 80% of its population are urban dwellers. The country is also in a late stage of its demographic transition, meaning that fertility is almost at its replacement level, and birth rates are relatively low. At the national level, the scenarios are clear. However, researchers in Mexico have pointed out that both urbanization and demographic transitions may be at different stages across regions and states. So as this presentation unfolds, I'll be presenting and highlighting some of these regional variations, particularly regarding urbanization, migration, and population age structure. And we chose to focus on these outcomes for three reasons. First, because they are and will continue to be major defining trends in the 21st century. Second, because they are interrelated. And third, because of the implications climate change may have for these outcomes and vice versa. And now that I mentioned climate change, know that Mexico's geographic characteristics increase its vulnerability to climate change. Future climate change scenarios for the country show that in most of the territory, the annual mean precipitation will be reduced, leading to increased surface aridity and more droughts. And other parts of the country, particularly in the south, are also expected to experience extreme seasonal storms and intense rainfall. So this summary of the context within which we are, and we will be running the community demographic models, it's just to say that studying historical and plausible demographic and urbanization trends is important for analyzing the socioeconomic and environmental development pathways for the Global South and at subnational levels. Next. Okay, so this graph shows differences in urbanization trends across Mexican states from 1950 to 2020. Note that except for Mexico City, which is at the top and it's a black line, and shows a clear pattern of stagnation, the proportion of the urban population has increased throughout time across all states, but nevertheless, urbanization patterns are not converging. We can see that the differences in terms of percentage points between the less and more urbanized states in 2020 are very much alike to those in 1950. So after seeing these regional variations, we ask ourselves how future urbanization trends across Mexican states may look like, and then decided to apply a CDM model for projecting them to see if throughout the projection horizon, the patterns would converge or not. Next, please. Okay. So these maps shows regional variations in the number of international immigrants throughout time across all Mexican states. Historically, the heartland for international immigration, particularly to the United States, has been Mexico's central north region. You can see the states in the bright red. However, over the past 30 years, new sending states have emerged, especially in the south. And for Mexico, a few studies have explored the relationship between climate and international migration, mostly from rural areas where households may employ migration as a strategy to mitigate some of the effects of climate change on agricultural livelihoods. I mean, we feel that future research may explore forecasting international immigration, which combined with climate change projections may add to the growing evidence that links climate impacts to migration. And this evidence might be used to design and implement livelihood-based support programs aimed at increasing adaptation to climate change in sending regions or communities. And next, please. All right, so this population pyramids reveal markedly different characteristics for two Mexican states. For instance, relatively low fertility and medium growth for Nuevo León, which is in the north region, and a pyramid with still a broad base of young children and narrow apex of older people for Chiapas, which is in the south. And these are just two examples that show the differences in population age structures across Mexican states, which also imply different demographic futures. So given that the pace of population aging is much faster than in the past, and that other populations are more vulnerable to health threats brought by environmental changes, we feel that population projections are important to investigate these changes over time. Next, please. All right, so when it comes to urbanization, results for selected states such as Nuevo León and Baja California Sur, and these are results from the urbanization projection model. So show possible paths of increasing urbanization under the central scenario. And for instance, Baja California Sur also shows future urbanization and stagnation and decline under the slow scenario. On the other hand, results for Oaxaca, which is a state located in the south and where less than 60% of the population live in urban areas, show a wide range of future urbanization trends. We are actually working on a paper that discusses these results into more detail and in terms of Mexico's urbanization and economic development disparities across the states and regional differences in vulnerability to climate change. But I mean, this is important because in a country like Mexico, which is a middle income country, urbanization has been associated with economic growth and poverty, but also to extensive land use change, growing energy consumption, and increasing greenhouse emissions, which have been identified as major contributing causes of climate change. In addition, in many Mexican cities or in semi-arid regions where water resources are limited and climate change induced droughts are expected to exacerbate water scarcity and increase heat waves and heat island effects. On the other hand, we have urbanization in coastal zones, which has also been increasingly rapidly. And the development of coastal tourism centers has increased the flow of internal migrations employed in the construction and tourism services, but also the rates of international retirement immigration. So you can see the connections between urbanization, migration, and also the changing population age structures. And well, finally, coastal cities in Mexico and throughout the world are expected to be affected by high incidence of cyclones, hurricanes, and tropical storms, as well as by sea level rise, which will increase urban population's vulnerability and exposure to risk. Next, please. Okay. In addition to the urbanization projections, we estimated population projections under a constant rate scenario, which assumes that throughout the horizon of the projection, which goes from 2015 to 2100, fertility, mortality, and migration rates will remain constant. So these maps show projected internal migration flows between Mexican states in 2050. The purple map shows in-migration flows to Baja California Sur, whereas the one below the penguin shows out-migration flows from Jalisco. Forecasting internal migration, if combined with climate change projection, may contribute to identifying regions or states where potential climate migrants are moving from and are moving to, which in turn may contribute to fill knowledge gaps regarding whether climate internal migrants moved either to urban, environmentally marginal, or more at-risk areas. Another thing that I like to highlight is that although these maps refer to international migration, CDMs have the potential to explore connections between internal and international migration. The main argument for this is that rural populations affected by climate change may first move into cities, which raises urbanization rates, and then move abroad to improve their economic conditions due to social and economic issues associated with urbanization. Next, please. As I mentioned before, the CDM allows to project population age structure. Here I'm showing you two maps. The first one, the one on the top, shows differences in the proportion of the population age 65 and above in 2050 across the states, and projecting population age structure and combining them with projections of climate change, such as the map below, which projects changes in average maximum temperatures, is of crucial importance for conducting research on the intersection of population structural change, consumption patterns, and climate change, but also on the impacts of climate change, mainly raising temperatures on the health of older adults that inhabit higher risk areas. And note that the second map shows projected changes in average temperature at the municipality level, whereas the map that shows the projected population age 65 and above in 2050 is at the state level. Nevertheless, the CDMs allows to estimate population structural change at the municipality level if data is available, which will provide much more accurate evidence. Finally, I'd like to highlight the potential of the CDMs for exploring the impact of future migration trends, both internal and international, on the population age structures of the regions of origin and destination. Next, please. All right. So climate change may also affect agricultural productivity and hence migration. However, linking climate-driven changes in agriculture and migration is highly complex and depends on several socioeconomic and demographic drivers that should be taken into account when working on these projections. To us, future research should focus on better understanding the context in which climate change may increase migration through agriculture. In this regard, and I'm going back to what Hamid said before, the CDM models have the potential to provide information on future changes in the proportion of the population working in agriculture, and explore if these changes could be associated with changes in average precipitation and or temperature. Next, please. All right, so as for the final remarks, I like to say that economic and social damages generated by climate change related events demand actions aimed at mitigating the damages and at adapting to increased risk. These actions requires a deeper understanding of the intersection of population dynamics, urbanization, and climate change through the generation of evidence on current and future risk and exposure to climate change. In this sense, we feel that the community demographic model is a good tool for generating high impact evidence, which will allow to improve our understanding of the plausible impacts of climate change on different aspects of the population dynamics at the country, state, and even at the municipality level. And we feel that this is fundamental to reduce people's vulnerability and, of course, reduce future risk and exposure. And we hope that at some point this information will be used by policymakers to design policy and programs across multiple levels that might lead to coordinate efforts to foster inclusive growth and livability while increasing the people's resilience capacity. I mean, we know that, we see the potential of the CDM models. We are aware of the challenges when it comes to availability of data, but we certainly, there are things that we can work out, and that'll be it, I guess, for my presentation. Thanks, Corinne, and thanks everyone for your attention.
Thanks very much, Ricardo, for your great presentation. We have around 10 minutes for the Q&A session. And I'm gonna ask our panelists to please try to respond to the questions quickly so that we can do account as many questions as possible. So I'm gonna start with this question, and I think Brian could be the best person to respond to it. So the question is, my understanding of the SSPs is that they are disjoint from climate change. They do not attempt to incorporate feedbacks from climate change impacts, but serve as inputs to a more integrated model. Is the same true for the CDM results?
Yeah, and so first, that's correct about the SSPs, right? And this is kind of a common misconception. Lots of people look to the SSPs for the answers, like, well, how much is it going to cost to reduce emissions? What are the impacts going to be? But as the questioner has correctly said, they are inputs, right? We kind of create worlds that don't have impacts or emissions reductions in them, so that they can be used by people who are studying what the impacts might be or how much it might cost to reduce emissions relative to that world where those things are not taking place. And so the CDM takes the same approach, right? Is that it's kind of starting with projections that don't have these effects in them. But the point is to use it then to then be able to incorporate such impacts. And I think that would be a nice thing to aim for with the CDM, including the interactive website, is to be able to look at, say, spatial projections for the US or otherwise, with and without effects of climate on migration, for example. Right, Hamid, as you know, we're working on a paper right now, trying to finish it up, that has some projections of climate impacts on internal migration. And we could include that in the future. It would be nice to do that with international migration as well. So that's the idea.
Yeah, thanks very much, Brian, for your quick response. I think the other question is about maybe Deborah or Brian, either of you can respond to this question. So it says that one city might be growing rapidly, but the world might be in a low urbanization environment. When using the SSP framework, are we assuming an unrealistic level of worldwide homogeneity? So I think it goes back to this this conversation about extending the SSPs and taking into account more localized determinants. But I'm just curious to see your response to this question.
Brian, go ahead.
Well, I was going to give, I mean, I kind of typed a long answer to Warren Sanderson, who asked this question, and it is kind of a tricky one because it's really ultimately sort of a scenario methodology question. So I think that broadly speaking, it's true that the SSPs in general and these global scenarios more broadly beyond the SSPs tend to create futures that we can think of more as like benchmark representatives of broad kind of global, maybe differentiated at the level of large world regions, but certainly not so much at countries or even city level. And the reason is to say, well, suppose the world went in this direction. Like, so for some of the SSPs, it's very high inequality, very regionally oriented, not very globalized, versus a world that very broadly speaking is sort of the opposite, quite globalized, less inequality. And that's useful for kind of broad brush comparisons. But the real world, we know, is much more likely to be a mix of those things. But and it's really useful to create scenarios that do have a mix: fast urbanization here, slow urbanization there. Some cities fast, other cities slow. The problem just comes down as if you're only going to create a small number of scenarios, 3 or 4 or 5, where the point is for lots of people to use them, not just in one study. Then if you pick one of those idiosyncratic things where New York doesn't grow fast, but Miami does, and then you base hundreds and hundreds of research papers on that, then all of your conclusions are contingent on New York not growing fast and Miami growing fast. And so these sort of plain vanilla scenarios are more produced for that reason, so that you have less chance of your results being heavily influenced by sort of idiosyncratic assumptions about heterogeneity. So in the end, what do? Well, maybe individual researchers create more variance with, you change the plain vanilla thing to say, hey, yeah, in SSP1, maybe the whole world is urbanizing rapidly, but maybe this part of the world doesn't, or this part of the country doesn't. What would happen? And you do a study based on that and just make a variant of this sort of plain vanilla scenario.
Just adding to what Brian is saying, I think that having the SSPs as a container in which some of the more localized work can happen, and expanding on that work, and maybe diverting a little from learning from what we've learned from the scenario development, but maybe using other tools. There are communities of people who do work on narrative development, that is, producing future narratives that are a little different than in the scenario space, but they can take the scenarios as a starting point. So then you can have, like, these are narratives that are consistent with 3 different SSPs. And I think we want that flexibility. I don't think that I think we're at a very novel stage of thinking about how to apply the SSP frameworks to particular localities. Of course, the more locality is like a mega region, like a mega city, maybe it's a little easier. But so those are some challenges ahead for this work. And in Ricardo's presentation, it made me wonder how much potential heterogeneity is masked a little bit by not having finer grained, say, migration scenarios. Like maybe people, when they experience many years of drought, move Mexico's already predominantly urban, but maybe the few remaining non-urban residents experiencing high drought move to the nearest city to them, and that would not actually even be captured in the migration data because it's a relatively local move, for example. So, and maybe those are not exactly tipping points, but like if we miss that part of the process, we may then poorly miss the next portion of the process where somebody has an interstate migration or something to that effect. And Lewin, your hand is up, so I'm going to pass. I'm going to mute and pass the baton to you.
Thank you, Deborah. We are trying to do the subnational urbanization population projection SSP consistent, and Ricardo shows the efforts we are working with Mexico. We are also working in many other countries like China, India, Pakistan, and yeah, we would like to understand the heterogeneity across the countries and based develop scenarios based on their social, economic, environment context. And the CDM model just provide the tools and the methods for people can work on that, or can develop those kind of scenarios. I echo what Brian said earlier. CDM model was developed to meet the challenge and overcome many barriers in the developing population projection for scenarios. And it provides the model and tools that are available for timely users. And it allows developing consistent scenarios according to the socioeconomic and environmental context at the global, national, subnational, and spatial levels. It also adopts some methods. There are also questions about asking about the methods. I don't have time to go through that, but I want to mention that we try to use the more advanced methods and demographic methods and data sciences and to robustly project the changes in population size, composition, and distributions, reflecting the demographic megatrends. We try to provide an open source for community use, contribution, and collaboration. So maybe this is just a start at the conversation, and we are open to all the questions.
Thanks very much, Lewin. Thanks again to our panelists, presenters, and attendees for this webinar. We hope you all enjoyed these discussions as much as we did, or even more. We will continue to share news, updates, and resources with you about the CDM and its development. In the meantime, you can reach out to us through the CDM contact page. We look forward to more conversations, collaborations about the role of this freely accessible tool for various applications in the human environment dynamics. Thanks very much and have a great day.